The domain errors are not exceptions. You must have heard that 1,000 times before, so let it be 1,001 today. Then what are they? There are two questions to answer. First, why distinguish domain errors from exceptions? And second, what should we do when a domain error happens if we are not to throw? I'll briefly answer the first question here because there is already an earlier video in which I have explained the nature of exceptions. The principal issue is that exceptions propagate up the call stack. There is no guarantee that anyone will handle an exception thrown inside a domain operation, let alone handle it appropriately. The exception might be caught several calls up the call stack, where that error doesn't even belong, or the handler doesn't understand the situation that caused it. The entire problem stems from the dynamic nature of exceptions as they propagate along the call stack rather than through the return value of each call. Again, please refer to my earlier video about the exceptions alone. You will find all relevant links in the description. That brings us to the second question: what should we do instead of throwing? I've already hinted at the answer. You can propagate domain errors through the return values of the domain methods. Consider this small example, which is very illustrative. There are three methods here. Method A is the ultimate caller. It uses method B as its dependency to perform a calculation. However, method B has a dependency of its own on method C. The critical aspect of this situation, which you must be aware of, is that method A doesn't know anything about method C. That is quite typical in practice. It doesn't depend on the other method or understand its results. Yet the error specific to method C is bubbling up into method A, where it is being handled. That should not happen in a well-designed system. We expect every component to maintain a well-defined interface toward its callers. So let's forget exceptions completely and start thinking about passing the errors as part of each method's result. I will build this same set of methods from the bottom up, because that is how errors propagate. The error originates somewhere down the call stack and propagates towards the outermost callers. I've called the namespace static scoping because I plan to transfer the domain errors through variable assignment and method returns. So if we want to design method C, we immediately face the obstacle of propagating errors. In the previous implementation with exceptions, this component used to speak in terms of I/O errors, network errors, or timeouts. These errors used to be exceptions before, and I used to throw them when the problems happened. This time I want to return them as the result of the method. The return type of method C will not be int anymore. It will be the result of int or error C. You can learn a lot about the result type from my previous videos. The short story is that a result either contains a positive outcome or an error. An operation cannot just return the value. Its return type must indicate the possible error. Let's assume that this method may experience random connectivity issues. It might return a failure result containing the network error. Another possible failure would carry a timeout. If everything went well, the method would return a success result containing the calculated value. This method depicts the principle of propagating domain errors via method returns. That makes it a certainty that the immediate caller will act upon the error rather than letting it bubble up to a different component. Let's see the calling code then. It would be the component B, which uses component C as its dependency. This component would speak in a different language compared to component C. Its possible issues include detecting an invalid request or arithmetic issues. I will now implement the coordination between these two components. Before that, let me point out that you can download the entire source code from this video and all other videos from my Patreon page. Please remember that every registered patron is helping hundreds of other fellow programmers watch all the content on this YouTube channel for free. Let's focus on implementing this component now. Ignore the particularities and focus on the fact that these errors differ from those raised by component C. The operation would use component C as the dependency and call its method to obtain a value. That is some modulo in this example. Ignore that and focus on error propagation. The type of this modulo is result of int or error C. The result of method B would be result of int or error B. These two error types are not assignable to each other. If calculating the modulo fails, we cannot just return that result. That is how exceptions work. You can throw anything that ultimately derives from exception, and the compiler would be fine with that. But that doesn't work this time because the two sets of errors are not assignable to each other. This component must translate each error from its dependency into its proprietary error type. Component C has introduced those network-related issues. Component B may see them as errors that are either transient or fatal. Component B would be indicating to its caller whether it makes sense to retry the operation. That is how the language changes from one component to the other. To map an error C into an error B, we use the map error extension method on the result. A network error would become a transient error. Anything else would be a fatal error. This code shows how you propagate domain errors across components in the software system, where each component speaks its own language and has its own set of possible domain errors. I will pull this logic into a helper method. To calculate the modulo of the argument, we call method C, which either returns an integer or an error C. We map the integer by applying the modulo operation as we used to. This will only happen on success. Any error becomes an instance derived from error B. This component also recognizes its own error conditions. There will also be a method that validates the input before performing the modulo operation. A negative argument causes an invalid request error. A large value causes an arithmetic overflow error. Either way, there is no point in continuing. Only for arguments within the legal range will this operation return success. You can see how errors can happen inside this component or come from the components it calls. A well-designed component reacts appropriately to both sources of errors. We can finally implement method B in a way that safely propagates domain errors to its caller. We first obtain a valid argument which might succeed or fail. Then use the functional extension bind on the result to chain the getModulo operation. I strongly suggest you learn the usage patterns of the result type. They are essential for clean error propagation in complex systems. This portion of the code will first validate the argument, either producing an error that specifies what's wrong with the argument or confirming that the argument is valid. Then, if and only if the argument is valid, it tries to obtain the modulo value and apply the modulo operation. However, obtaining the modulo might also fail, in which case the error translation will happen. So regardless of the outcome, we always end up with either an integer result or an error B that is part of this component's documented API. Finally, we get to component A, which uses component B as a dependency. Component A doesn't propagate any errors further, it will always produce some int result. Depending on the error, there are predefined return values. These are the documented results of this component. The method needs to call the dependency and pass the argument to it. This call returns a result, either an integer or an error B. Producing an ultimate integer result is easy when working with statically scoped results. Nothing else can appear here but error B, because the only way to receive anything is through the return value of method B. We handle that easily with the monadic extensions of the result type. Match the success case by applying the arithmetic transform. Handle the failure by applying the error translating method. This is what well-structured domain error handling looks like. Nothing can leak from component B's dependencies into this code anymore, because the connection to further dependencies has been cut off. I will now show you how that works in some real code. You will also find a minimal API project here. One of the operations in that minimal API project parses a string from various HTTP requests into a culture info object. These strings are not under our control. We must validate them before processing any web request. The getCultureInfo method from .NET throws an exception if it doesn't recognize the culture name. I have opted to stop the propagation of that exception, because exceptions are not a good choice for expected errors. In case of an exception, I will package the message into a failure result. Otherwise, if the operation succeeds, I return it as a success result containing the culture info object. Either way, the return of this method will be a result of culture info or a string. Let me show you one of the places where I use this method. This is a very complicated piece of validation logic at the endpoint. You can watch my previous video to learn how this endpoint implementation evolved into this form. Many people say that validation should be simple, in one place, and so on. That is like believing in Santa Claus. Domain validation is one of the most complex parts of any software. It is a never-ending source of complexity. This example here is just a glimpse into that complexity. Among an awful lot of other data this endpoint receives, there are two culture names that require validation. The result of this method is also a result, either a success with all the fields from the web request validated or a failure. That is the same error translation you have seen in the toy example. Every layer in your application and every component will speak its proprietary language and return errors from its own dedicated set. Unlike exceptions, you cannot accidentally receive an error the origin of which you don't understand.